This question says the speed of 55 cars passes through a certain section of a road in Johannesburg and are monitored for 1 hour the day after the alcohol ban was lifted in August. The speed limit on this section of the road is 60 kilometers per hour. A histogram is drawn to represent the data. Okay, so this is your histogram, right? We can see that for each block, this here is 20 to 30. That's the speed limit or the speed range. From 20 to 30, you just have one car, right? 30 to 40, you have 7 cars. 40 to 50, you have 13 cars, and so on and so forth until you get to 90 to 100, which there is only one car driving at that speed. Now, the first question says identify the modal class of this data. If you're identifying a modal class of the data, you're looking at the one with the highest frequency. And from here, the one with the highest frequency is the one with the highest bar, from 50 to 60, which is 17, right? So our answer for this is just going to be from 50 to 60. Then B says use the histogram to complete the table below. Okay, so we need to input the data that we have for our frequency and substitute into our table over here, right? So the next we need to calculate our cumulative frequency, and to do that we're just going to be adding the total with the next class, right? So it's like 1, add it to this, which is 8, add it to this, which is 21, 38, 47, 52, 54, and 55. Now our last cumulative frequency has to be the total of, if you add all those frequency, it needs to give you 55 at the end. And we know it's 55 because in the question it said the speeds of 55 cars. And the next question wants us to draw an Ogive, right? A cumulative frequency graph for the above data. Now, drawing your Ogive, we need to concentrate on these values, the upper limit of our class, and our cumulative frequency. We also need to include the first class. That's the only one we take the lower limit, and it must be like this, right? Okay, so let's plug this in. So this side is your cumulative frequency, right? And on this side here, this is our speeds. All the points has been plotted in our graph. It all comes from this table. As I said, each of your upper limits with your cumulative frequency, all we just need to do is connect the points, right? And don't forget to always start from the first lower limit and start from the x-intercept, right? So it will be 20 and 0. Okay, so let's just connect this point. Okay, I'm going to reduce it a little bit so I can get everything. There we go. So this is exactly how our cumulative frequency graph is going to look like, right? Our Ogive graph. Now for C, it says the traffic department sends speeding fines to all motorists whose speeds exceed 66 kilometers per hour. Estimates the number of motorists who receives a speeding fine. Since we're looking for speeds above 66 kilometers per hour, we need to look at, okay, so 66 will be here. And we need to plot it to where it intersects with our graph, right? So we draw a line. So let's draw a line. So now we need to also look at what the corresponding cumulative frequency from 66 kilometers is going to be. So 66 kilometers per hour is going to be. So we're just going to draw this. And it is more or less going to be here. So this here is 45. Now at 66 kilometers per hour, the cumulative frequency is 45. Now, because they're asking us for exceeding that amount, what we need to do is subtract the total amount of motorists from that 45. So to get our answer, since our total motorist was 55, we subtract 55 from 45. It will give us 10. So we can say that 10 motorists would receive a speeding fine. So that will be our answer. That's it.